Good morning to everybody. Today I am going to handle the subject called automobile engineering. In general, if you ask any youngsters, what is your dream after your graduation or you have joined in a job? Most of them will answer, I want to own a car, because car is a dream for everyone. So the field automobile engineering is flourishing a lot because of the dream of the many youngsters. So today let us take a complete review of the subject automobile engineering. Especially I am going to handle the main components of the automobile and also the main components of the engine of an automobile. In this regard, I have made the sequence of order in such a manner everyone can understand in depth about automobile. Automobile. What do you mean by automobile? The name itself, automobile. Auto means it's a self. It moves itself by having power on its own, by generating power on its own. That is called as automobile. So let us have some definitions of automobile. Automobile is a wheeled vehicle that carries its motor and moves with passengers, or goods. And also it is a self-propelled vehicle. That means the power of that particular mobile, the power needed for moving that vehicle will be taken care by the power plant which is provided in the automobile itself. So that is the definition of automobile. And if we are going to see in detail about it, the history of this automobile, it is not a single person invented this automobile. It was invented by many people in due course of time, in 16th century, 17th century, 18th century, like that. So the most important part of invention is having an IC engine, that is internal combustion engine. That type of vehicle have been invented by Mr. Benz, who invented this particular self-propelled vehicle with an IC engine, internal combustion engine. When he invented this particular engine, it was running at a speed of say 2 to 3 kilometers per hour only. So, but in those days it was a great invention. The people have wondered about that invention and they were just loved to have such type of things. If you are looking into that, that will be a very old vehicle. Let us see in detail about all these things one by one. Now let us see the categories of automobile. Automobile is being categorized under many categories. It is based on number one, body of the vehicle. If you are looking at the body of the vehicle like a car, lorry, bus, a scooter, anything. Based on that body, we are going to specify that what type of vehicle it is. Number two is fuel. In any automobile, we have to give fuel as input and we are going to get rotary motion as output. That's the basics. When we are seeing as an input, either it can be a petrol vehicle or diesel vehicle. This is about generally IC engines. Nowadays we have solar powered vehicles, electric powered vehicles and many other things like gas, CNG, etc. etc. Then number three, utilization. Whether the automobile is going to carry human beings, that's passengers, or it is going to carry any goods. If it is a passenger carrying vehicle, it can be a bus, car, etc. etc. If it is a goods carrying like lorries and trailers, etc. Then number of wheels. Based on number of wheels also we are categorizing the automobile. It can be a two-wheeler, which is loved by most of the youngsters. And number two, it may be a three-wheeler like an auto, a four-wheeler, a car, or it may be a six-wheeler, a bus. Nowadays even buses are having more number of axles like multi-axles vehicles. So to have the more sophistication, we are going to build the vehicle in such a manner, the entire cabin will have all the facilities like that. So that is utilization part of it. Then wheel drive. What type of wheel drive? Whether it is the drive is going to happen in the front wheel or the rear wheel. Sometimes it's four-wheel drive also. Front wheel drive means the drive is going to happen in the front wheel, front two wheels. Modern cars, most of the modern cars are having this front wheel drive only. The engine will be fitted at the front and the drive will be shifted to the front wheels only. So when it is the case, we are going to have the drive directly from engine to the wheels. When it is being driven like this, the loss of transmission will be minimized. That's why most of the modern cars are front wheel driven vehicles. And in olden days when it was invented, it was rear wheel drive. The back end of the vehicle will have two wheels. Those two wheels will be propelled by the IC engine. So when it is a rear wheel drive, that drive will get the power from the engine which is mounted at the front. Through the propeller shaft it will come and it will be driving the rear wheels. So due to that many losses, transmission losses are happened. When it is evolved, they are shifted from rear wheel to front wheel drive. And there are some vehicles which needs all the four wheels to be driven. It means, suppose if we are traveling in a muddy region or it's a beach which is having more sand or it is a very water area like a river or anything. In such condition, the vehicle has to be driven by four wheels. Then only it will move comfortably without any disturbance. So this type of vehicles will have the drive in all the four wheels. For that, the drive is from the engine will be given to a gearbox, a special type of gearbox. From that gearbox, it will be splitted into two and it will go to the front wheel and rear wheel. So in such a manner, the four wheels can be driven very comfortably. That is called as four-wheel drive. Nowadays you might have seen in some jeeps and even in some sport utility vehicles, we used to call it as SUVs, they have the four-wheel drive. Then capacity of the vehicle, whether it is carrying 2 persons or 1 person, 3 person, 4 person, accordingly it is being categorized. And the type of transmission. Transmission in the sense, the power from the engine is being sent to the wheels. That wheel has to propel the vehicle by rotating the wheels mounted in the four wheels. When it is being shifted like that, the transmission can be manual, semi-automatic or it can be fully automatic. Manual means the clutch has to be operated by the driver itself. There are semi-automatic, partially it is being operated, then fully automatic. The fully automatic vehicle will not have a clutch pedal at all. So the entirely it will have only the accelerator and brake. So when we press the accelerator, automatically it propels the vehicle comfortably. As per the required torque, that system will accommodate the torque, adjust the torque so that it will be being propelled. These are all the categories of automobile based on these features. Now let us go to the next. When we go for the types of automobiles, we can see different types. You can see some of them. This is cargo, especially used for carrying the cargo. This is convertible, which can be converted, the top of the body can be converted by having a layer of cloth or anything like that. This is crossover, coupe, which can carry only 2 people. This is minivan. This is hatchback. Nowadays you can see many vehicles which is not having a goods carrying cabin at the rear. That is hatchback. This is a luxury model. This is truck, partially it is open. Then we have performance car, sports cars, motorcycle, wagon, and many more designs. These are all some of the types of automobiles. As per the type of body that is being fitted over the automobile, we are getting these type of things. Let us see some. The first one is hatchback. I told about it in the previous slide itself. This is the sports car. It's a 4-door sedan. We call it a sedan. And this is limousine. It is a lengthier model where you have a lot of space in between the front wheel and rear wheel. And it is so comfortable. It is used by many luxury people. This is convertible. This is hard top. The top of the vehicle is fully covered by metal. And this is a van and pickup truck. And apart from this, we have the arrangement of cylinders in the IC engine. There are many types of arrangement of cylinders. The first one, inline. The inline means all the things are arranged in a single line. A conventional automobile is having this type of engine only. 1, 2, 3, 4. It's a 4-cylinder vehicle. It is inline. All the cylinders are arranged in line. The movement will be like this. And this is called as V-type engine. V-type. The cylinder arrangement is in V-type. 2-cylinder will be this side. 2-cylinder will be this side. This is for making the engine more compact in nature. Especially sports cars are designed for getting more power. It needs more power. Maybe we may be increasing the number of cylinders. By increasing the number of cylinders, we can get more power. Suppose it is a 12-cylinder engine. We have a 12-cylinder engine also. A 12-cylinder engine. If we are going to arrange all the 12 cylinders in line, in a straight line, then it may not be possible to have a longer crankshaft. When you are having a longer crankshaft, that will make the crankshaft so discomfortable, and it may make the vehicle to make some problems in the running of the vehicle. For that, 6 cylinders have been arranged in this way. 6 cylinders have been arranged in this way, and they have been made just 50% of the length. If it is going to be arranged in a single line, 12 cylinders, 6 cylinder this side, 6 cylinder this side, and it is being made like this. The length of the crankshaft also have been reduced to 50%. So in this way, when we do so, the vehicle will be very comfortable and very compact in nature, and we can get good power. And this is flat engine. The next one what we are seeing is a flat engine. It is a horizontal one. The cylinders are arranged in horizontal and the pistons are arranged in the same plane itself. These are all some types of arrangement of cylinder: inline, V, and flat. This is about the drives. Already I told about it. The drive, this is a front wheel drive. You can see here, this is the front end of the vehicle, this is the back end of the vehicle. The engine is being fitted like this, not like this. You can see the red color. Engine is being fitted like this. The power is coming out and is being driven like this. It is given in between the front two wheels. When it is so, you can see that front two wheels will be driven using this type of things. So this is called as front wheel driven vehicle. This one is a rear wheel drive. In this, inline engine is being fitted in line with the axis of the automobile. So the power will be driven using the drive shaft and the differential. The rear wheels will be driven. This is called as rear wheel drive. And we have this as 4-wheel drive. This is a 4-wheel drive where this is the engine, this is a flywheel, clutch, and the gearbox. We have a special transfer box. We call it as transfer, which transfers the torque to the front and rear of the automobile. Here it is being split into two. One goes to the front end. The front end is having a differential, and another shaft is going to the rear wheel. That is also having another differential. So the both front wheel and rear wheel can be rotated using this single engine. It is called as 4-wheel drive, which is used in military purpose and special purpose things. Now let us go into the main components of the automobile. If we are broadly seeing the main components of the automobile, number one is the basic structure. We call it as chassis, over which the entire system, entire automobile is going to be fitted. That is called as basic structure. Number two is power plant, which is very important for the automobile for propelling the vehicle. It can be of anything. In case of a normal conventional vehicle, it is IC engine. If it is an electrical vehicle, it is a motor. If it is some other source of engine, it will be something else. So that is the power plant. Then the transmission. The power produced in the engine has to be transferred to the wheels, which is having direct contact with the road. How it is being transferred? That is transmission. The transmission of the power or torque is happening through two media. Number one, clutch. Number two, gearbox. Clutch is doing the function of engaging and disengaging. When you want to change the gears, we have to do this. That's the purpose of that. I will show you later. We will see later. Then gearbox is doing the function of getting different torques. We need not have the torque constant. Initially, when you move the vehicle, you have to give more power to the wheel, then only the automobile will move. When it is running in a highway or it is a very good smooth road, we need not have the same amount of torque needed for that. So when we want to have different torques with different speeds, we are going for a gearbox. These two things are very important. Apart from this, there are some other components like propeller shaft, which is used only in the rear wheel drive, and a differential for dividing the power into two and drives to the two wheels. So that is the transmission. Then an automobile cannot run just like that. It will run, no problem. But we should have a control over that automobile. If you don't have a control over that automobile, it may meet with an accident. So we need some controls over the automobile. We have two controls over that, major controls. I am talking about the major controls. One is brake. When you want to stop the vehicle, we have to use the brake. Then number two is steering. To steering means directing the vehicle, whether it has to go to the right or left or straight. So these two things are controlling the vehicle. We call it as control. Then auxiliaries. Apart from this, we have many auxiliaries. Electrical system, cooling system, lubrication system, fuel system, everything. These are all other things apart from the routine operation of the engine, that is automobile. And we have some sophistication in this part also. We have, when we go for sophistication, it can be a audio system fitted in an automobile, or it can be a video system, audio video system that is being fitted in the automobile. Sometimes if you are going for some very high-end cars, they have refrigerator, air conditioner, etc., etc. All sophistication, what we enjoy in our home can be done in the automobile itself. All these things are coming under auxiliaries. Finally, we come to the superstructure. After fitting this engine, transmission system, ancillaries, etc., we are going to have a shape, give a shape for the automobile for a proper utilization. If it is going to carry passengers, then it will be fully covered. If it is going to carry the goods, it can be partly covered, or special type of vehicles like ambulances, then maybe a fire engine, or it may be a earth moving equipment. Earth moving equipment means, in the sense that this particular earth moving equipments will be used only in mines or off-road. We used to call it as off-road vehicle. It is not used on road, it is off road vehicles. This type of vehicles also that they are coming under the category of special type of automobiles. So this is about the main components of automobile. Let us see one by one, and let us see in detail about the engine alone at the final stage. Just now I explained about the main components. These main components are being shown in this diagram very neatly. You can see here, this is the engine part. You can see here oil pan, this is engine part, and this is the crankcase also, and here it is the transmission. Then it is being shifted by propeller shaft. Here we have the differential, the rear wheel drive. It's a rear wheel, back wheel drive vehicle. The transmission is happening. Apart from this, we have the radiator for cooling, power steering, line shaft, exhaust system, and gas tank, shock absorbers for smooth functioning, smooth movement of the vehicle, and tires, hydraulic converter, then master cylinder for brakes. So this is about the layout of the main components of the automobile. I will show you another picture. In reality, actual view from bottom of a SUV. It is a sport utility vehicle which is having the entire system. I will show you the parts. This is called as basic structure. You can see it's a rectangular part which is made of metal. So this is called as chassis, over which the entire thing is being mounted. This is the engine part. This is a bigger size engine, and this is the transmission. I told about it. It is a clutch, and this is a gearbox. Then it is being, this is a propeller shaft, differential, rear axle, and this is the output from the engine. That is a silencer or muffler. We used to call it as muffler. These are all the tires. This is a fuel tank. In general, an automobile will be consisting of engine, transmission, tires, chassis, and superstructure is being avoided. When we want to have a complete view of the automobile, we should have a car-like shape or bus-like shape or anything. Based on our utility, we are going to have. When we talk about the basic structure, I told it's a chassis. Already I have shown it in of a SUV. Here in this diagram, this is the chassis. It's one of the old type vehicle. This over the chassis only the engine is being fitted, and the transmission. This is a three-dimensional view. You can see in detail about all these things. You can see the universal joints. Here you can see this, how the power transferred to the differential is being split into two to the wheels. Then you can see springs. This is for smooth running of the vehicle. When you run the vehicle, if the road is having more bumps, then it will jump or it will be moving like this. So if it is directly fed to the chassis without any shock absorber or anything, that will affect the comfort of the passenger. To avoid that, what we do is we are fitting a component called a shock absorber or leaf spring. We call this as suspension for smooth functioning of the vehicle. That is this. You can see here the shock absorber and the leaf spring. You can see the rear end also. Here and here we have the shock absorber, and this is the steering, and which is connected to the steering box, which controls the vehicle. And just below that we will have a brake pedal, which is used for stopping the vehicle when it is needed. This is a general picture of a power plant, which is an important component in an automobile. So generally power plant is of anything. If it's an electrical vehicle, it can be electrical motor. It's an IC engine, internal combustion engine. It's a complete view of the engine. This engine will get the fuel from the fuel system. Either it can be a petrol or it can be diesel. If it's a petrol engine, it is going to be spark ignition. If it's a diesel engine, it is going to be compression ignition. The difference, if you are looking at the difference between the spark ignition and compression ignition, combustion, what we need is combustion of the fuel. We have to burn the fuel in an effective manner, in a closed container. That's what is happening inside a IC engine. It's a closed container. When it's a closed container, when you are igniting it and blasting it, then obviously it gives a lot of energy. That energy is being transferred to the piston, then to connecting rod, then to crankshaft, it rotates. The input should be a fuel, the output should be a rotary motion generally. So in this engine, if it is a spark ignition system, it is going to have either it can have a carburetor or it may be a multi-point fuel injection pump. If it is a compression ignition system, obviously it should have a fuel injection pump. In compression ignition, the input will be air only inside the cylinder. Then it is being compressed fully by the piston. At the maximum pressure, the fuel is going to be injected at very high pressure. Due to that, the ignition of the fuel, that is firing of the fuel, takes place. That gives the power. So now I think you can understand between the petrol engine and diesel engine. This is about transmission. Next main thing in automobile. The transmission, I told you, there are majorly we have two things. One is clutch, which is used for engaging and disengaging the gearbox from the engine when you change the gear. First gear to second gear, second to third, or sometimes fourth gear to second gear even. Whenever you change the gear, you have to apply pressure over the clutch pedal when it is a manual transmission vehicle. When you apply pedal, what happens? So this is the clutch, simple clutch. You can see here by the left hand side it is disengaged condition. You can see here. Pedal pressed down. The driver is applying the pressure over it, and this is the disengaged condition. Then you can see the gap in between this. You can see a minute gap. Here, very minute gap. Maybe a 2 mm or 3 mm. That is enough to disengage the transmission from the engine to the gearbox. Then this is a engaged condition. You can see there is no gap at all. Pedal up. The driver is not pressing the pedal. So whenever you want to change the gear, you are going to press the pedal, change the gear, again leave it. The pressing and leaving of the pedal should be smooth enough so that there is no jerk is happening inside the vehicle. This is about the clutch, and this is the picture of a gearbox. Actually, whatever inside the gearbox, that is being shown in this picture. This is giving many output powers. The input power is going to be same. We can get lower torque, high speed, or higher torque, lower speed. That is possible in this gearbox. Then I was telling about the controls. This is a schematic diagram of a brake system where we have a master cylinder which is being operated by the driver, and these are all 4 wheels. Those 4 wheels are having 4 discs parallel to the tire, and those things are being stopped whenever we want to stop the vehicle using the pressure that is being built up in the master cylinder. So in the driver cabin we have accelerator, brake and clutch. When you stop the vehicle, when you are pressing the brake pedal, it applies the pressure over the master cylinder. This is the master cylinder. When we apply the pressure inside the master cylinder, it is having a piston and also fluid. That fluid pressure will be transmitting the whatever the pressure you are applying over the pedal to all the 4 cylinders. When it happens, automatically stops the vehicle. It makes the disc not to rotate, applying the pressure over the disc, and it is not allowing the wheel to rotate. So that's a braking system. And we have the steering system for control to go right and left side. This is steering column and this is a steering box. We have the linkages. this will guide the front wheel of the vehicle. There is no need for turning the rear wheels. Only the front wheels can be controlled very comfortably using the steering box. The steering box, when the driver rotates the steering, it has to rotate. It has to turn to the right. When he is rotating to the left, it has to turn to the left. This is happening by the mechanical system which is fitted inside the steering box. This is the steering box that makes that output, and accordingly through the linkages the front wheels are turning to the right and turning to the left. This is about the controls. Now let us see the main components of the engine. So already what we have seen is the main components of automobile. The engine is the most important part of any automobile, which is giving out the power. I have shown you a picture of that engine. Now let us see the main components involved in this engine. First one, cylinder block and crankcase. What is this cylinder block and crankcase? I was telling about the burning of the fuel. If the burning of the fuel is going to take place inside a closed container, closed room or container, then entire energy that has been exerted by that will be blasting that container. The same thing is happening inside the engine, inside the cylinder. The most important part of it, inside the cylinder only, the blasting of the fuel, the burning of the fuel is occurring. So it should be very hard enough to withstand all these things, and all the sides are closed. Only one side is having a moving component, which is called as piston. So it is having a closed container and is having a moving part. This closed container, inside that we are going to fire the fuel, and that time if it is the piston, it will move down, it will be pushed down. This motion is transferring the power from the blasting of the fuel to the crankshaft. How it is happening? The main components: cylinder block and crankcase. Crankcase means it is a cranking, means moving like this. That cranking of the things is happening in a case, closed container. That is called as crankcase. Then we have cylinder head. We are going to have a closing of the top end of the engine. That we call it as cylinder head. Then at the bottom portion we have a sump, or we call it as oil pan. Since the engine is having more number of moving components, piston, connecting rod, rotations and bearings, etc., it has to be lubricated properly. If it is not lubricated properly, then it will experience more wear and tear. Due to that, soon the engine will be bad in condition. That should not happen. For this, they have a lubricating system which is having a container at the bottom of the engine. We call it as sump or oil pan. That will be filled with oil. That oil will be sucked using a pump, and it will be fed to individual moving components of the engine. That is happening in this. You can see oil pan or sump when you see bottom side of the engine. I will show you some pictures later. Then manifolds. I told about the input to the engine, then output to the engine. When it is considered as an input to the engine, the fuels. As far as spark ignition is concerned, if you are going to use a carburetor, then you are going to mix air and petrol in the carburetor, and will be fed inside the cylinder through some manifolds, some pipes. We call it as pipes. That pipe is being called as manifold, inlet manifold, or it is a multi-point fuel injection also. The same principle is going to happen. And after burning of the fuel, the burnt out fuel has to come out and has to go to the silencer or muffler, whatever it may be. That is called as outlet manifold. This is called as that one, manifold. Then we have gaskets. When the firing of the fuel takes place, the block cylinder head is being mounted. When two parts are being made of metal components, there are more possibility for the escaping of the burnt fuel when the combustion is taking place. To avoid that, we are using a part called as gasket. This gasket will have two metal surfaces, top also metal surface, bottom is also metal surface. In between that, it is having asbestos composition, which will make the gap filled tightly. In domestic, in houses, we used to have, if for operating a proper functioning of a pressure cooker, the bottom and the lid will be there. In between that, we are using a rubber material, which is closing the gap between the vessel and the lid. So similar to that, in engine also we have cylinder block and cylinder head. In between that, we are going to have, wherever it needs, there is a possibility of leakage, we can use this gaskets. Wherever, not only in between the cylinder head and the cylinder block, many other places. I will show you some diagram later. Then it is cylinder. I told you where the combustion is taking place. Then it is piston. Piston is the only moving component inside the cylinder. All the head is closed, the liner is closed, the entire engine is closed. Only the piston is being moving up and down. It is a closed container. Firing takes place here, and this piston will be moving down. When the blast occurs, it is moving down. When it is moving down, it is connected to a component called as connecting rod. The connecting rod is connected to the crankshaft. Crank means it is like this, cranking, like a cycling of a pedal. When you pedal the cycle, what we do is we are applying the pressure over the surface. Actually, we are applying the pressure over the surface. That's a pedal, and this arm will be rotated like this. When it is being rotated like this, your downward motion is being converted into rotary motion. The same principle is occurring in engine also. So the movement of the downward movement of the piston is transferring the power to the connecting rod. The connecting rod is linked to the crankshaft that is being rotated like this. When you see the diagram, you can understand. Then it's about pistons. Piston is the moving component. We have a lot of things to be discussed. Then piston rings, which is more important. Again, the wall of the cylinder and the piston is having some metal. Both are metal. It is having some gap, but it is a moving component, not like cylinder head and cylinder block. It is a moving component. How the escaping of burnt fuel is not happening. Let us see about it. That's the piston rings are the main reason for blocking of the burnt out fuel escaping through that gap. Then connecting rods, the linkage between the piston and the crankshaft. Then piston pins. Piston pin is the pin which is used for connecting the piston and the connecting rod. Then crankshaft, which is the very important thing, which is at the bottom of the engine. Then main bearings, which is holding the main bearings are holding the crankshaft actually. It is a highly fastly rotating component in the engine, and it rotates like that at higher speed. That has to control the wear and tear. Lubrication is there. And valves. This is a very important component of the engine. Valves valve actuating mechanism. What's meant by that? The input of the fuel, input of the engine is diesel or petrol. That has to be fed to the cylinder in a proper timing, in a proper quantity. That's very important. If you are going to allow more fuel, that's danger. If you are going to allow less fuel, that's also, it will not function. So correct quantity of fuel has to be allowed and in correct timing. That's very important. In this regard, let us have a small discussion about IC engine. In an IC engine, what happens? We might have studied about all these things in 2-stroke and 4-stroke engines. In automobiles and cars, we are using only 4-stroke engine. In 4-stroke engine, there is a 2 valves. One is inlet valve, another one is outlet valve. Inlet valve allows the fuel air mixture in case of petrol engine. In case of diesel engine, it allows only air. as far as outlet valve is concerned, the burnt out gas is going to escape through in both. So this valve has to open at the right time and closes at the right time. If it is not closing, then what will happen? During the firing of the fuel, that is a combustion of the fuel, the entire things will come out through that inlet valve. So it has to be done in a proper way. That is called as valve and valve actuating mechanism. That has to be timed properly. So when actually what is happening in the IC engine is, the piston is moving, is the maximum limit of the piston is called as top dead center, and the lowest level is called as bottom dead center. When the piston is reaching the top dead center, then only the firing, the combustion of the fuel is taking place. So at that time, the valve, both inlet valve and outlet valve should be closed. When we need the fuel to be get in, then only the inlet valve has to be open. And when after the combustion is taking place, only the outlet valve should be open. If at that time, if the inlet valve is also open, then the exhaust gas may go through the inlet valve, which may cause some problems in the system. So this is about the valve actuating mechanism. Let us see in detail about that also. Then finally we have mufflers. The outlet, through the outlet manifold, the burnt out gas escapes and it goes through a pipeline which is going to a system called as muffler. The function of the muffler is, the main function of the muffler is to make the engine silent, to reduce the noise produced by the combustion of the fuel, because every time it bursts, cracking takes place. That should be suppressed. For that we have a system called as muffler. We use the other name for that is silencer. So these are all the main components of the engine. Let us see one by one some pictures and also the functioning, how it is functioning. First of all, let us see a complete operation of the engine. How it is happening inside the system. This diagram is a single cylinder engine. We have single cylinder engine also. Two-wheelers are having single cylinder engine only. How it is taking place? Let's see. This is the cylinder and this is the piston. And this is a, you can see here, spark plug. And this is exhaust valve, this is inlet valve. You can see here. And through the inlet valve, this is a carburetor. It allows the air fuel mixture, it gets inside. It's a T-type engine. Here it gets inside and is being accumulated here. And after that, the piston moves up. When it reaches the top pressure, the spark plug is being operated. Spark is being produced. Then combustion is taking place. When the combustion is taking place, inlet valve, outlet valve, everything is closed. Only the moving component is cylinder. Piston. The piston is being pushed down fastly. That is moving downwards. This is called as connecting rod. It is a connection in between the piston and this crankshaft. You can see the crankshaft, how it is being designed. It is not in a single axis, it is having a main axis and another axis by the side. That's what I was telling about an example of a bicycle. So a similar type of arrangement, this is happening. So this is a flywheel and other things. This is the oil pan for lubrication purpose, and this is the entire set of arrangement. We have some cooling system also. You can see here water pump, water jackets by the side of the cylinder, because cylinder is going to get more temperature due to the combustion of the fuel, firing of the fuel, no more temperature. To avoid that, we are having this cooling system. This is that, and we have the dynamo, etc., other components like that. This is a simple functioning of the engine. So fuel is being get inside through the inlet valve. The firing takes place. Piston is being pushed down through the connecting rod. It is connected to the crankshaft. The crankshaft rotates and also flywheel rotates. From the flywheel, we are going to get the drive to the rear wheels or front wheels, whatever you like. It's a multi-cylinder engine. You can see the components of the multi-cylinder engine. This is the valve. You can see here. These are all valves. 1, 2, 3, 4. Valve. And this is the camshaft. There is a longer size camshaft. You know what is a big cam? Cam is a component which is having center and eccentrics overlapping. Eccentric bumps, which is making the valve to open and close. As per the design of the manufacturer, the cam is designed in such a manner so that it makes the valve to open and close, open and close. So that is being done in that. So here this is a valve and the camshaft is being used, helping a lot in operating the valve system. And this is a distributor for distribution of the proper current through the spark plugs. And this is a spark plug directly. It's a V-type engine actually. It's a V-type engine. It's a piston, and you can see the crankcase. It's a multi-cylinder engine. Crankshaft you can see. This is a crankshaft. You can see the partial. The remaining part is inside. And this is an alternator for generating power, electricity, for storing in the battery. And this is a combustion chamber. When the piston is attaining the top dead center, there will be a small portion which is called as a combustion chamber. That's it. This is a cylinder, fuel injector. You can see here. These are all about the multi-cylinder engine. The next one, functioning of the engine. When it is being functioning, what is happening inside the engine? This picture will give you a clear-cut idea what is happening inside a multi-cylinder engine. Here, cylinder block, cylinder head, everything is being removed. It is provided with, you can see here, this is the crankshaft. It is connected to the various connecting rods. You can see here, connecting rods. These are all the connecting rods connected to various pistons. Totally we have 1, 2, 3, 4, 5, 6, 7, 8. V8 engine. It is a V8 engine. That is a cylinder, pistons. It is moving inside the cylinder. You can see here, firing is happening at the initial stage. At that time, the piston is at the top dead center. This particular cylinder, already firing had occurred. It has made the piston to go down. You can see the gap. This is less, this is more. And flames also you can see. After that, this is exhaust. Burnt out gas is going out. And these cylinders are in the process of getting the fuel burn. And these are all valves. And it is being operated using this camshaft. You can see the camshaft, how it is. It is having a center, it is having a bump like structure here and there. So this is cam, which is operating the valve so that it is doing very well closing and opening function very well when the combustion is taking place. This is the functioning of the engine. You can see the exploded view now. Very comfortably we can see each and every components of the engine, even drain bolt in a oil pan, even a drain bolt you can see here. How the oil inside the sump can be removed while it is being serviced. So completely it is exploded view. Let me tell you very shortly. Cylinder head cover. There will be a cover over the cylinder head also to avoid the splashing of the oil, lubricating oil. That is cylinder head cover. And this is the cylinder head gasket. And this is the cylinder head. And this is the gasket. And this is the cylinder block where cylinders are being provided. And this is another gasket. Here this is sump. And by the side we have the exhaust manifold this side, and by this side we have the inlet manifold. And this is water pump gasket, timing belt cover, this is camshaft pulley, this is the camshaft arrangement. Actually, when you run the vehicle, the engine should be properly timed. That is, only at the cylinder reaches the TDC, then only it has to be fired. At that time, the system has to function in a proper manner. So, timing is very important. It should not be in advance or it should not be prior to that, later to that. For that, we have an arrangement called as this pulley. can see here, that will be connected with the crankshaft itself. So when we want to open, you open. When you want to close, you close. That is the main purpose. This is an exploded view of the entire engine. And this is about the cylinder block. I told about the cylinder block. What is meant by cylinder block? It is a portion where the cylinders are being provided and inside which we are going to have the pistons. The explosion is taking place only in this region. So the walls of the system is going to have thicker. You can see the thickness of the wall. It's an inline engine. You can see the thickness, and here you can see some holes. There's a water jacket which cools the surface of the outside surface of the outer surface of the cylinder. This is an inline engine. This is a V type. This side 4, and that side also it is having 4. So totally it is 8 cylinders. It is having 8 cylinders. This 8 cylinders will make the engine so comfort. Okay. And this is the cylinder head which is being placed over the cylinder block for closing of the entire system. It should not have any openings. Only the piston has to is the moving part inside the cylinder. This is the cylinder head. You can see here. This is the bottom portion of the cylinder. These are all valves, and this is the inlet valve. This is outlet valve. Inlet valve, outlet valve. Inlet valve will be normally bigger in size. Inlet valve and outlet valve. It opens like this. It is opening inside the cylinder. Inside the cylinder. So this is the top surface of the cylinder head, where you can see the manifolds holes, and this is we call it as rocker arm. We call this is the rocker arm. You can see 1, 2, 3, 4, 5, 6, 7, 8. That mounting used for rocker arms is called as rocker shaft. This type of arrangement is being done for the purpose of opening and closing of the engine, valve. This rocker will be like this. For example, it will be like this. It will be moving like this, up and down. If you are going to move this up, this end will go down. If you are going to move it down, this will go up. Like a normal seesaw what we used to play. It is called as rocker, rocking system. Since it is similar to that, we call it as rocker. This rocker arm is used for transferring of the opening and closing of the system using a camshaft which is mounted at the bottom. Normally we have two types. One is in one type of engine, the camshaft will be at the bottom level, and another type will have at the top level itself. It directly opens and closes the valves, whereas this system will have a rocker arm like this, which is mounted over the cylinder head, or we call it as engine head. Functioning of the cylinder head, how it functions. Cylinder head functions, you can see here. I told about the camshaft, this is the camshaft, and this is a lifter, and this is the valve, which is fitted with the help of a spring. Always the valve will be in closed condition. Simply by applying a pressure over this surface, we call this at this surface, applying a slight pressure over the surface. This will be moving this valve downwards and allowing anything coming through this inside it. That's all. That's the main function of the valve. So it is happening here. This is a overhead cam. This is also a overhead cam. You can see here rocker arm. It is in a separate condition. Here directly it opens. Here through the rocker arm it opens. It is a lifter. It is being operated with this, and this is called as rocker arm, which is making action like this. So here it is pushed down against the pressure of this spring, and it allows whatever maybe a fuel or exhaust gas water inside it. There will be a connection between this part and this part. So it is a functioning of the cylinder head. And this is the complete exploded view of the cylinder head. If you are looking into the cylinder head, you can see even bolts and nuts, even tappets, and this is cylinder head, and these are the holes are manifolds, fitting holes, and this is the provision for making the rockers fitted over that. And here you can see the holes. Here also you can see the holes. And these bolt and nuts are being used. And even small components. If you are looking into the valve is actually fitted through a small hole against the loaded spring. The spring is always make the valve to be closed. We are applying pressure over the valve at the top end of the valve, and we are applying the pressure. Slightly we are applying the pressure. The pressure needed for opening the valve will be very much, and that is being done using a camshaft. Camshaft is applying the pressure over that. Against the load of the spring, it opens inside. It opens inside, and it allows the fuel to get inside. That is the main function of this exploded view. Now we come to the bottom portion of the engine. I told you the bottom portion of the engine will have an oil pan or sump. We call it a sump. It is used for storing of the lubricating oil at the lowest level of the engine. Here you can see here, this is the sump. You can see many bolts and nuts which is used for mounting it to the bottom surface of the crankcase. Because the lubrication, everything should happen only the inside the moving components, wherever the components are moving, that should be done. So this is the sump, and you can see the bolts and nuts, and this portion is very deep. This portion will have a stainer for the purpose of filtering of the oil, because when the lubricating oil is taking a long path inside the engine, that may bring some small scraps or small metal parts inside that has to be filtered properly. There will be a stainer. Through that there will be a small pump which is pumping the lubricating oil, and it supplies to the various moving parts of the engine. That is being done. This is actual photograph of the sump in an automobile. You can see the bottom surface. This is sump. And when it is manifold, I told it may be a inlet manifold which is used for allowing the fuel inside the cylinder, or it may be a outlet manifold which is sending the burnt out fuel outside through the muffler. These are some samples. This is it's a manifold. The accessories needed for mounting it, and this is a gasket again, which is sealing the gap between the manifold and the body of the engine. And here it is a mounted thing. You can see a large type of large engine which is having manifolds, inlet manifold, outlet manifold. This manifolds will do the function like this. Then I was telling about gaskets, which is not allowing any gaseous part outside. So that is gaskets. Normally the gasket is being placed in between the cylinder head and the cylinder block. And wherever this type of application is there, we can use this gaskets. So this is a cylinder gasket. You can see the holes, bigger size holes for movement of the piston. And this is the water jackets holes, and everything is there. And this is a 3-cylinder engine gasket. And these are all gaskets which are being fitted in oil pumps, or it may be some manifolds. Wherever applications needed, we can use these gaskets. And cylinders. The cylinder can be a general line. That cylinder can be a general line. That directly it may be having a system in the cylinder block itself, or it may be having a liner which can be separated separately. As far as liners is concerned, we have dry liner and wet liner. Dry liner and wet liner. If it is a dry liner, it is not having direct contact with the water jacket. If it's a wet liner, it will be having a direct contact with the water jacket. So these are all some type of cylinder liners. And piston. Piston is the only moving component inside the cylinder. This is a sectional view of a real-time engine. Sectional view of the real-time engine. You can see here. This is the cylinder. This is the moving piston. 1, 2, 3. We have 3 pistons. 1, 2, 3. You can see the top surface of the piston. How it is. This hole is being provided and the pyramid-like structure. You can see the pyramid-like structure. It is being provided for uniform distribution of the fuel throughout the combustion chamber. Uniform distribution. So when the firing takes place, the fuel should be burned fully. That will be done only when the uniform distribution of fuel is taking place. For that purpose, actually the inlet valve allows the fuel inside at this point only, and it is allowed. This pyramid-like structure will distribute the fuel. You can see the curved surface. It will be like a donut. It will be like a donut. It will distribute the fuel very comfortably throughout the chamber uniformly. At that time, spark is taking place, spark is occurring, so firing will be very uniform. So this is the purpose. I told about the piston, and you can see some grooves. 1, 2, 3. They are called as grooves. The provision for the grooves are piston rings. We have to provide piston rings to avoid the escaping of the burned out fuel. The burned out fuel should push only the piston downwards. It should not escape through anything else. So that is the main purpose. This is the grooves provided for rings, and you can see the connecting rod. This is the crankshaft. This is the complete about the piston. And about piston rings, I was telling, you can see here what are the types of piston rings. The top of the piston is having a ring called as top compression ring. Top compression ring, it is used mainly for compressed. Completely it closes the gap between the piston and cylinder. That is called as compression ring. And second also, again, there are many possibilities for escaping of gas through that. That should be avoided. Even the second stage, it should be blocked. This is the second compression ring. You can see here. You can see some holes also. Actually, spring will be like this only. Like this only. There will be a gap. So that when it is in cold condition, it is being like this. When it is hot, after the engine started, it has to expand. That comfort should be given. So this is the top compression ring. It's the second compression ring. Third one is oil controlled ring. What is the need for this oil control? Where comes the oil? I told about the lubrication of the entire engine. That lubricates the friction making component, that's the piston and walls of the cylinders also. The walls of the cylinders are being splashed with lubricating oil. Splashed. That splashing should not go beyond the piston. Should not go above the piston. If it goes above the piston, what will happen? When combustion taking place, even this lubricating oil also will be burnt. Because oil is also more or less a petroleum product. It also burns and it will be consumed by the combustion. It should not happen. So for that, we are providing a oil controlled ring, which is while the piston comes down, the oil controlled ring swipes, simply it swipes and gets the oil downwards. Actually lubricated, the walls are lubricated, it is already wet by lubricating oil. When it comes down, it wipes and comes down. If it is not wiped, what will happen? It will reach the combustion chamber. That combustion, when it is in the combustion chamber, during the firing, it also burns. To avoid that, we are using this one. So first one is the top compression ring. Second one is second compression ring. Third one, oil control ring. Here we have other things, piston pin, for locking that we have the snap ring. We call this portion as the piston crown. Actually this surface will be designed like that, which I have just shown you one slide prior to this. Here you can see here. And this is the piston skirt. This name of this side portion is called a piston skirt, and this is a connecting rod shaft, and this is the big end of the connecting rod. We call it as big end of the connecting rod. These are all the bolts, and we have the bearings inside for connecting with the crankshaft. And this is the actual photograph of a piston and piston rings. You can see the different shapes of the rings. You can see how it is. There is a top compression ring, second compression ring, oil ring. That compression ring will have a small spring-like structure inside it for a proper fitting of the entire system. When you see in a minute manner only, then you can see it. Then I was explaining about the swiping of the oil and other things. How it is taking place, you can see here. This is the cylinder, this is the top compression ring, second compression ring, and this is the oil control rings. 1, 2, 3. You can see here also. This is a two compression rings, and this is the oil control rings. What is happening? You can see here. I told about a spring-like structure inside that. You can see here also spring-like structure. That simply wipes the oil that is being splashed over the surface of the inner wall of the cylinder and swipes, and it allows the oil to pour into the sump, directly into the sump. So that is happening, how it is happening, you can see here. Here and all you just see, this is the film of oil. This film of oil is being swiped downwards. Then the remaining compression will do the function of the blocking the burnt out fuel which is burnt at the combustion chamber. The diagram, you can see it's very comfortable. This swiping of the oil, it pours inside the sump. Now it is connecting rod. After the piston, small end of the connecting rod, there should be a connection between the piston and the crankshaft. Then only up and down motion of the piston will be converted into rotary motion. That is the main purpose of that. The up and down motion of the piston, the motion of the piston is happening by the fuel burn. It is moving up and down. That movement, the up and down motion, has to be converted into rotary motion. How it can happen? Only by having this type of system, which is called as connecting rod crankshaft. You can see here how it is being. This is the small end of the connecting rod, which is connected to the piston, bottom portion of the piston, and this is the connecting rod. This is the big end of the connecting rod, which is connected to the crankshaft. Crankshaft will have offset axis, which is connected like a bicycle. It is moving like this. That is possible only this. You can see this diagram. This is a connecting rod bearings. This is a real-time picture of a connecting rod. Here this is small end of the connecting rod. This is a big end of the connecting rod. This is the connecting rod bearings. Because the connecting rod, the big end of the connecting rod, is making a rotation like this always. But this is the crankshaft. It will be there will be a lot of relative motion between these two. That should be minimized. To avoid the friction, to reduce the friction, we are lubricating that area, and also we are having a spring, bearing, which is a normal conventional bearing. This is the connecting rod bearing. It is made of two offs, one at the top, one at the bottom. In between that only we have the pin of the crankshaft. You can see this conventional manufacturing. This is some connecting rod manufacturing. It is manufactured using stampings. And piston pin. Actually, equally, piston pin also exerting more power. When you are transmitting the power from the cylinder to the crankshaft, this you can see here. This is small end of the connecting rod. it is being connected to the piston. So the up and down motion of the piston has to be linked to the connecting rod. The amount of energy exerted by this will be much more. That's why the thickness of the pin, that is a piston pin, is being made thicker, so that it can withstand the whatever may be the amount of energy that is being exerted. Quickly it will happen. So this is the piston pin, locking, snap ring, and this is the connecting rod bushing. It is also having a bushing. It is also having a relating motion, and this is a pin boss, which is a provision for locking the pin, and this is a piston. This is a connecting rod, and this is a real-time piston pins, various types of piston pins that is being used in automobiles. Now we come into the important component, which is called as crankshaft. It is simple, if you tell, it's doing the function of a cycling. The up and down motion of the piston is being converted into rotary motion. That is happening using this. I was telling you about the main axis. This is the main axis of the crankshaft. And there are many pins made in offset, that is away from the main axis. You can see here, this is the main axis. Actually, if you are looking at this pin, first pin, this is away from this. This is the main axis, and this is away from this. That is why I call it as offset. This is again main journal. This is main journal. This is main journal. This is also main journal. Main journal means actually it is being attached with the crankcase and the bottom portion. And this is 1, 2, 3, 4. These 4 things are crank pins, which is offsetted away from the main axis by the side to get the power from the respective cylinders. As per the manufacturer's specification, we are going to have one at this side, one this side, one this side, one this side, like that, for uniform distribution of the power. Because when it is a 4-cylinder engine, continuously we are going to get the power from, for example, the firing order is 1, 4, 3, 2. First cylinder burst, firing takes place, then 4th cylinder, then 3rd cylinder, then 2nd cylinder. If it is the order of firing, then 1, 4, 3, 2, 1, 4, 3, 2, it will run in a sequential manner like this, 1, 4, 3, 2, 1, 4, 3, 2. At that time, each and every part will be functioning. The respective connecting rod will be operating, respecting pins will be operated. Those things are this. We call this as crank pin. And these things, you can see some added weights, this side, this side, this side, this side. When it is rotated like this, it has the power got as output from the engine should be uniform. It should not have up and down motion. If it is like that, then our car will go in a jerk, like this, like this, like this. It should be avoided. For that, they have designed the crankshaft in such a manner. There is a counterweight. You can see here, counterweight. This is, we call this counterweight. This, and this. These are all counterweights to balance the engine in a proper manner. Already when the firing occurs, we got the power. Other times, what will happen? The counterweight will take the equal load, and the output will be smoother. For the smooth functioning of the engine, these counterweights are playing an important role. So here we have mount for camshaft, drive sprocket, main journal oil way. You can see the oil way. I was telling about the oil, how it is being circulated. You can see here, this is one oil way. Here you can see another hole. Here you can see another hole. Here you can see another hole. These oil holes are connected from here, drilled through like this. So when the pressurized oil is being sent through this hole, it will go to the inner part and will lubricate this part, and it goes like that. It's one of the important part of the engine, Crankshaft plays a major role. The manufacturing of crankshaft itself, it is entirely a different system. It should be properly designed. The design of the crankshaft should be pakka. Then only the engine will run in a smooth manner. This is a real-time photograph of a crankshaft. You can see this is the main axis, and this is the pins and counterweights. You can see here. Counterweights are designed in such a manner it has to balance the power got from the cylinder. In that way, it is being designed. These are all main bearings. Main bearings are the bearings. It's a off-off, a circular off-off, a simple mechanism by which it avoids the friction in between two moving components. You can see here. This is engine block. Here, these bearings are going to be mounted here, like this. One off like this. Inside that, crankshaft pin will be there. That's all. You can see the block showing the cap stretch, and these are the real-time photograph of the main bearings. You can see holes and the grooves also. You can see the grooves. You can see the grooves. Grooves for the purpose of lubrication. The passage for the moving of the lubricating oil to lubricate the friction-making areas. Then comes the valves. Valves is a very important thing I told. At the proper timing, proper quantity of fuel should be let in, and it should open and close in a proper manner. For that, we are using the system. You can see here how the valves are being mounted. This is the valve. This is called as valve guide. This is called as valve guide bed. Valve guide. Valve should not deviate from its action. It should be properly mounted in such a manner. It is not moving right, left or front, back like that. There is a valve guide seal. Spring which is always making the valve to be closed. Always keeping the valve to be closed. And this is the valve guide. Then valve spring retainer. We have to retain the valve always in closed condition. Only when it is needed, it has to apply. When you are applying the pressure, it has to open. That's all. So here lock spring, and these are all the different components that is being used. And this is the same arrangement. This is a real-time photograph of a valve, many valves, different types of valves. And valve actuating mechanism. How the valves are being actuated. Here you can see. I told about different components, guide, spring, lock, everything. It is being in closed condition. Now, this camshaft will be always rotating by the power got from the crankshaft. And this camshaft will be rotating. This, when it is rotating, this is in closed condition. When this bump portion that is provided in the cam is coming down, and it touches this lifter, what happens? It pushes down. That bump pushes the lifter down, just down, against the load of the spring. The spring always makes the valve to be closed, and it is being pressed against the force of the spring, and it allows it to open. Then it opens, then this chamber and this chamber will be connected. When this bump portion crosses that area, again this spring takes into action and it closes the valve. It's a very simple mechanism, but somewhat efficient mechanism. Only at the time when this bump comes here, then only the valve opens. Here is another set of arrangement with rocker arm. I told you it is like a rocker arm, like this, up and down motion. Here it is the rocker, and this is the rocker is pushing down against the load of the spring. This we call it as lifter. In some engines, the camshaft will be at the bottom portion, by the side of the cylinder itself. When it is in that way, we are going to have a rotation, comfortable rotation, by which it lifts. There will be a rod that lifter rod, and it comes to the through the rocker, and rocker pushes it down, the valve opens. That is the system. You can see here. When it opens, this chamber and this chamber, this is the combustion chamber, this is the inlet, both are being connected, opens and closes. So it's a valve actuating mechanism. I was telling about the push rod and all. You can see here, it's a crankshaft, it's a belt or chain, camshaft is rotating. When camshaft is having the bump, you can see here, and valve lifter works, lifter is pushing the push rod upwards, and it is connected to the one end of the rocker. When it is pushed up, what happens? This end will come down, will come down, will come down. This coming down will make the valve to open. You can see here, this is mounted like this, this is an inlet manifold, and it pushes it down, then obviously the valve will be coming down and allows the fuel to get in, filled, closed. After the bump is crossed, it is not giving any pressure, closed. This is a valve acting mechanism. Then it finally comes to the mufflers. What is meant by muffler? It's a silencer, I told it. The outlet manifold gets the burnt out fuel, gas, waste gas, and comes out with sound, with noise, lot of noise. That has to be suppressed. How it is being suppressed? It is actually the exhaust pipe line, and we have the muffler here. The inside structure of the muffler will be like this, having some partitions as per the manufacturer's design. There will be holes and other things. Apart from this exhaust pipe will have an important part called as catalytic converter. You can see here. The catalytic converter neutralizes the poisonous gas coming out of the engine, like carbon monoxide. It has to be converted into carbon dioxide using a system called as catalytic converter. That is being also done in this way. So this is about the muffler, and this we call it as black gas. You can see here. This makes the sound of the higher sound of the noise of the burnt out fuel to lesser level, and so that we feel when we are riding the vehicle, we feel very comfort. So that's the end of my automobile engineering class. If you have any queries, please ask.